Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss ideal constant voltage source and ideal constant current source. Let's begin. Voltage source means voltage provides to that of electrical circuit is known as voltage source. Constant voltage source, an instrument which provides voltage output continuously to the load connected across is known as voltage source. Constant voltage source known as voltage source, it provides voltage continuously to that of load any kind of instrument like resistor, capacitor, inductor which opposes the flow of current through that of circuit is named as the load. How the concept of ideal constant voltage source? In case of constant voltage source, in which the voltage source has low internal resistance as comparison to that of external load resistance. Otherwise, we can say here the internal resistance be 0, then that source, that constant voltage source is named as an ideal constant voltage source. So, an ideal constant voltage source has 0 internal resistance. Okay. The ideal constant voltage source is of two types. One is DC voltage source, one is DC voltage source, another one is AC voltage source. DC voltage source, another one is AC voltage source. So, what is DC voltage source? DC voltage source, it is that instrument which supplies direct voltage output continuously to that of load, to the load connected across it, and the polarity of the output voltage, the polarity of output voltage remains the same. In case of direct current, DC voltage source. Some examples of DC voltage source: as voltaic cell, Lagrange cell, Daniell cell, dry cell, battery, DC generator, are some examples of DC voltage source. Look here, we draw a circuit when a DC voltage source is connected across a load resistance. This is the load resistance RL, which is connected to that of DC voltage source. There will be the key K, voltage source V, current I. Here current I flows in the circuit, and that voltage source provides an internal resistance. It has an internal resistance smaller. So the current I flowing through the load resistance RL, therefore current I is given as the potential divided by the net resistance, that is RL load resistance plus internal resistance of that of voltage source smaller. Here I is known as the load current, and the terminal voltage across the load resistance is V. So the terminal voltage here, terminal voltage is the voltage across the load resistance, that is the voltage across the load resistance. V be the voltage across the load resistance. Terminal voltage is equal to voltage across the load resistance, that is equal to V, the terminal voltage. Therefore the voltage drop is given by, therefore here the voltage drop is given as, that is voltage source minus current into internal resistance R, or that can be further be written as, or we can write, that is current load resistance RL, that be the potential drop here in case of DC voltage source. Now in case of AC voltage source, it is the instrument which supplies alternating voltage output voltage output continuously to the load current connected across it. And the polarity of the output voltage in case of AC. In case of DC, the polarity of output voltage remains same, but here the polarity of the output voltage reverses periodically in AC voltage source. And some examples of AC voltage source. Examples like AC generator, oscillators, function generators, are some examples of AC voltage source. Take an example of a circuit. When an AC voltage is connected across a load, here is a load having impedance ZL and current I flows through it. This is the AC source, current I flows through it. And the current I to that of circuit can be given as I, that is ZL is the impedance of that of load, that is the impedance of load, as the opposition provided in case of AC circuit is known as impedance. So, Zi be the internal impedance here in that of case, for that of source it has an opposition. So, Zi be the internal impedance. So, I is equal to V, that is the potential, divided by sum of the impedance. Since these impedances are connected in series, that will be ZL plus Zi, impedance of that of load, impedance for that of internal source. And the terminal voltage across the load impedance, the terminal voltage, therefore terminal voltage across load impedance is equal to, that is the voltage drop, we can say V minus I Zi or I ZL. Okay. Look here, when the internal resistance or internal impedance of a voltage source is 0, if that one be the 0, then we can say there will be no such voltage drop here. So, the voltage drop will be 0. It is difficult to realize the ideal voltage source in case of practical situations. However, small values of internal resistance or internal impedance can be considered as very close to ideal voltage source. Okay. This is for ideal constant voltage source, DC voltage source and AC voltage source throughout the example of a circuit. Now, ideal constant current source, the instrument which provides current to that of circuit is known as current source, and if it will be continuous or constant, then known as constant current source. And in case of ideal, the current source which supplies constant current to that of load. Here in case of ideal, the internal resistance be at infinity, and the ideal constant source, the instrument which provides current to the load connected to it is known as current source, and ideal current source is that which provides constant current to the load, and it is denoted by representation of ideal current source and the representation of ideal constant current source, ideal constant current source. A constant current source is that which source has very high internal resistance as comparison to that of external load resistance. Taking a circuit here, a circuit, it has a load, the impedance of that of load ZL, that is connected to ideal constant current source, it has internal resistance, internal impedance Zi, in ideal constant current source, the internal resistance is at infinity. However, an ideal current source is not possible in reality case, but a current source often used in case of laboratories is an ideal current source in parallel with that of internal impedance Zi, which is known as the internal resistance of R. It has internal impedance. This is the source providing internal impedance Zi, and internal resistance here smaller, that is the practical current source, that one is the practical current source, practical current source. So the load current, the current through that of load impedance ZL, that is also known as the load current. The current through load impedance ZL is given by IL load current, that is I ZI current into internal impedance divided by its sum, that is ZI plus ZL. Now dividing ZI in case of numerator and denominator, so IL is equal to I divided by 1 plus ZL divided by ZI, ZL divided by ZI. The current through the load impedance, here IL is equal to I, IL is equal to I when ZL is very less than ZI. Hence current source provides a current, constant current I to the load connected to it if the load impedance that is ZL is very low, is very small as compared region to that of internal impedance ZI. It has an internal resistance smaller, where IL is equal to I, load current throughout that of circuit. So with the help of this video lecture, we understand the concept of ideal constant voltage source, its classification as DC voltage source and AC voltage source, its example, circuit diagram. Next, ideal constant current source, circuit diagram and its representation. So with this useful and informative notes, let me wind up this session. Thank you.